The purpose of this video is to introduce you to the techniques used to name alkenes. Remember that alkenes are molecules that have at least one carbon-carbon double bond within the molecule. In this video, we're going to focus on how to name molecules that have just a single alkene group. In the following videos, what we're going to do is look at molecules that have more than one alkene group and how we would determine the names of those compounds. In a later video, we are also going to be looking at how to assign the stereochemistry of an alkene group within the name of the molecule. But for now, what we're going to focus on is just coming up with the name for the structure without specifying the stereochemistry and with a focus on just molecules that have one alkene group. So let's go ahead and get rolling with that. So it would be a really good idea to review back to the quick start guide to naming alkanes, because we're going to be using these guidelines and adapting them to talk about naming alkenes. So let's go ahead and go through these guidelines and talk about what modifications we need to make in order to name an alkene rather than naming an alkane. So we're focusing now on molecules that have at least one carbon-carbon double bond within the molecule. So first things first, find the longest carbon chain to assign the parent name. That is going to be true here as well for naming alkenes. The caveat that we need to add here is that the parent name, that longest carbon chain name, must include the alkene group. So it has to include both carbons of the carbon-carbon double bond. So look for the longest carbon chain that includes both carbons of the carbon-carbon double bond to determine the parent name. The parent names of alkanes, molecules with just carbon-carbon single bonds, all ended in ane to emphasize and indicate that the molecules we're dealing with now are alkenes. What we're going to do is take these ane suffixes and make them ene. There is no such thing as a one-carbon alkene, so we can pretty much ignore methane, but ethane would become ethene, propane would become propene, butane, butene. You get the idea. All the way down the list here, all the ane suffixes become ene suffixes. Now keep in mind when we're talking about alkene molecules that the carbon-carbon double bond can vary in location along that chain. For example, the carbon-carbon double bond could be between carbons 1 and 2 of the chain. It could be between carbon 2 and 3 of the chain, et cetera, et cetera. And so one thing that we will have to specify in the names for alkenes is where that carbon-carbon double bond is located. So in order to identify where that carbon-carbon double bond is located, we need to talk about how we're going to number the longest carbon chain. So step 1, we found the longest carbon chain. Step 2, we're going to number that chain. And for numbering for alkenes, we're going to number beginning at the end closer to the alkene group. So unlike when we were naming alkanes, where we started numbering from the end closest to where a branch came off, instead, here, alkene groups are going to take priority for deciding which end of the molecule to start numbering from. So we're going to start numbering from the end closer to the alkene group. So looking at this business about numbering from the end closer to different branches, that's really not going to apply here, because when you have a molecule that has just a single alkene group present in the molecule, you'll always start numbering from the end of the molecule that's closer to where that alkene group resides. Then from there, what you're going to do, based on the numbering system you've come up with by numbering from the end close to the alkene group, is then here at step 3, you're going to name each of the alkyl branches in alphabetical order before that alkene parent name. And I should add here, as we're going through this list of criteria, once we number that parent chain, and we're specifying where the alkyl branches are, we also have to specify where the alkene group is located. So in the parent name, right before the name pentene, for example, you would indicate what carbon number is where the carbon-carbon double bond starts. So you must specify the location, in other words, the carbon number where the carbon-carbon double bond begins, because putting the carbon-carbon double bond at different places along the chain would lead to different constitutional isomers. So let's go ahead and do an example here of applying these different guidelines toward the nomenclature of alkenes. Okay, so let's take a look at this example problem where our goal is going to be to come up with the IUPAC name for this molecule. So we're going to go through this list here from our guide for naming alkenes. And the first thing we need to do is find the longest continuous carbon chain. And remember that that longest continuous carbon chain absolutely has to include the carbon-carbon double bond. That's going to be one of the ways that naming alkenes differs from naming alkanes. So find the longest carbon chain. All right, so looking for the longest carbon chain that includes the carbon-carbon double bond, what I find is that if we start over here at the right-hand end of the molecule, work our way through, our longest carbon chain is going to pass right like so. Taking a look at this, we start numbering the longest carbon chain, beginning at the end closer to the alkene group. So the alkene group takes priority in deciding how to number this chain. So therefore, we're going to start numbering from the upper right-hand side here, because that's the end of our chain that is closer to our alkene group. So I'm numbering this all the way through to 9, and therefore, since we have 9 carbons in our chain, the parent name for this molecule is nonene. And we do need to specify where the alkene group begins. So the first carbon that has the alkene group is carbon number 3. So therefore, we call it 3-nonene. That implies that the carbon-carbon double bond is between carbon 3 and carbon 4. The synonym for that is that we could have also referred to this as non-3-ene would also be acceptable. In different versions of the IUPAC guidelines, you'll see these two different terms used, and we can use them synonymously. The purpose of putting the 3 as close to the ene as possible is it's to emphasize that the alkene group is at carbon number 3. But either of these two ways to go about naming are totally accurate and acceptable. Then from there, what we'll need to do is go ahead and name our branches. So we have a branch here at carbon number 8, which hopefully you recognize as a methyl branch, and we have a branch at carbon 5, which is a little bit more challenging here. That branch we could refer to as either our sec-butyl branch, going back to the alkyl group names that we talked about several chapters ago, or you could also refer to this alternatively by looking within the branch, start numbering the first carbon from the branch is carbon 1, 2, 3. We could also refer to this then as a 1-methyl, because at carbon number 1 of that chain there's a methyl group. So a 1-methyl propyl group. 1-methyl propyl is synonymous with a sec-butyl group. So then we plug these branch names in at the beginning here as our prefixes. So we'll go ahead and do that. Methyl and sec-butyl, we'll go ahead and plug in, including their locations. So our methyl group is at carbon number 8. So we'll call this 8-methyl, M coming before S in the alphabet. And then at carbon number 5 of the chain is where our sec-butyl group is located. So we'll go sec-butyl, and then dash, separating letters from numbers, 3-nonene, or you could have just gone straight from butyl into non-3-ene with no space required between butyl and non. Alternatively, if we call this a 1-methyl propyl group rather than a sec-butyl group, it would end up being referred to as 8-methyl 5, and then we have to put into parentheses here the 1-methyl propyl. So what the parentheses indicate to us is that everything in parentheses here is located at carbon number 5 of the chain. So our 1-methyl propyl is located at carbon number 5 of the parent chain, and then after the 1-methyl propyl comes our 3-nonene, or alternatively our non-3-ene if you prefer to do it that way. So 8-methyl 5 parentheses 1-methyl propyl 3-nonene would be an alternative way to go about naming this molecule. Now keep in mind here that in this particular example we haven't talked about or shown wedges and dashes to illustrate the stereochemistry at the chiral center. So we have within this molecule one chiral center. Remember, the chiral center is defined as a carbon that has 4 different groups bonded to it. So our chiral center there is indicated with a star. But since we have no wedges or dashes appearing at that location within the molecule, although it is a chiral center, we can't specify it as R or S. So we're pretty much done with the name right here. In a future segment, we will be looking at how to specify the stereochemistry of alkene groups right here, because we're going to see that many alkene groups can be defined as being cis or trans, or alternatively as so-called E and Z configurations. So we will look at that in a future segment, but for now, since the objective of this video is just to get comfortable with looking at the names of alkenes, we have accomplished that with the particular example that we've done here.